Good morning. How's everybody's Ignite been? Good? Ours has been great. We've really had a lot of fun here. Server 2019, GA, getting to talk to people about containers. Every year we get a little bit more excitement around containers. We see more people using them in production, more people getting the advantages of them. So we're really excited to be able to come here and talk to you again about what we're doing with containers, what's in Server 2019, and kind of this transition from ops to DevOps. My name is Taylor Brown. I have the distinct honor of leading the container PM team for Windows containers. And I'm joined today by Craig.
Hey, guys.
And so without further ado, let's go ahead and get started. We got a lot of content. I always try to put up the slides ahead of time. So if you want to grab the slides, take a look at them. If this isn't the session you want to be in, find another one. If you want to grab the slides and use them for another presentation, they're there to use. You want to take them back home, whatever you want to do, feel free to grab them. They will be available afterward as well, but we always try to make them available just to get started with. So to kind of start off, I want to think a little bit about how we got here. There's kind of a chain of technologies that have really fundamentally impacted the way we think about computing, right? We can think about microprocessors and kind of the birth of personal computing. We can think about how the internet led to distributed computing. Right before we had kind of this connectivity, we didn't have anything like distributed computing. We didn't really think about how pivotal some of these moments really were until after the fact, and until we use them every day. One of those times was really virtual machines. Right, when I started playing with virtual machines, it was because it was cool. I got onto the virtual machine team right after Microsoft acquired ConnectX, back almost 15 years ago, and it was because I thought it was just a cool technology. I had been doing development, and our development stack required 16 servers. So in order to actually test out anything, we had a small deployment that was 2 servers under a desk, and at the time, that was really painful. I spent most of my time re-imaging SQL Server. That was not particularly useful. And so when I started seeing virtualization, I was like, wow, this is a really cool thing. And it was just really neat to play with. What I didn't really understand at the time is how pivotal virtual machines were going to be to the way that we think about computing. Right? They provided this abstraction between the physical hardware and the operating system, which contained my application. And so all of a sudden, I could move that application around. I could redeploy it. I could bring it from one server to another server. That gave us live migration. That gave us the ability to do all these interesting things, right? It was really a pivotal technology. And I think back on kind of where that brought us, and it really started to bring us to a new way of thinking about how we manage the world. We got the birth of the cloud, and that kind of started us down this path towards DevOps, right? All of a sudden, we were automating things. We were scripting them. We were taking things and mitigating them through a PowerShell script, or at that time, a VB script. And that was really the birth of DevOps. And I often, when I talk to people about DevOps, I have to kind of remind them that it started with ops. This was not a term that started with dev. It started with ops teams figuring out how to automate things, running on attend scripts, doing those kind of things. And what's really kind of disappointing is that now, when I talk to people about it, especially ops teams, what they hear is dev, right? It's like, hey, this is a dev thing. And well, yeah, fine, we'll bring the ops team along. And I think that's really unfortunate because really this movement started with operations being more efficient. And I think if we think about that and we kind of bring back to, what was that and how do we bridge these things together, we have an opportunity to really change that. And so as we go through the session today, that's one of the focuses that we're really going to have is how containers help us think about this kind of DevOps practice and how they help the ops side and the dev side come together, right? So foundationally, what is a container? We talk about it, we hear about it. What is it? At a really high level, it's just another abstraction. So we talked about virtual machines kind of abstracting physical hardware, the physical servers that we had things installed in, from the guest operating system and the application installed. Containers are kind of the next step in that. So we're taking the application and we're abstracting it from the guest operating system. So now we can move that guest application around. We can move that app around without having to worry about the guest operating system. And we'll get into a little bit of how all of this works under the covers. But think about what that actually means. Just like with virtual machines, all of a sudden I could live migrate the guest around, and I could redeploy it into a cloud, and I could move that around. Think about what I could do if I can just move the app. I don't even have to worry about the guest anymore. I don't have to worry about the configuration of that guest operating system. Its name, its IP address, whether it was patched or not, what things were installed in it. Did someone come in overnight and change some of the configuration of it and forgot to update it, and now we don't even know how to redeploy it? All of those things become erased when I can just think about the application itself. And that's really why containers have become so popular. It's because they've given us a way to abstract the application from the operating system.
And so before we dive in and actually look at what exactly a container is and we pick apart what a container is, the first thing that I think we need to talk about is why containers, and then after that, who containers. So to answer the why, the first is that containers are really gaining momentum. And this has been evidenced to me by the constant stream of folks who have been coming to our booth this week. And some of you have already been sharing success stories with containers and how you are transforming your workplace and gaining agility. Others of you have expressed excitement about containers, but you're still not quite sure what containers are. And then still another gentleman I was talking with yesterday, actually, he walked up to me and he said, "Craig, I finally get containers, and I'm drinking the Kool-Aid." And that was kind of funny. We shared a laugh, but I think the reality is that containers are more than just a sip of Kool-Aid. And the reason for that is because of the agility that they provide. With the lightweight nature of containers, you can stand them up quicker, you can take them down faster. And so what we see is containers actually churn a lot faster than VMs. So 9 times faster than VMs according to the Datadogs. So what that means is with VMs, you're thinking about this instance is running for a matter of days or months. With containers, it's more a matter of minutes, hours, perhaps a couple days. Now, the second thing is that because containers are so lightweight, we see that customers run generally more containers at a time than virtual machines. And Microsoft is not the only company who acknowledges this containers momentum. Gartner, in their 2017 Smarter with Gartner publication, asserted that by 2020, more than 50% of enterprises will run mission-critical containerized cloud-native apps. 50%. That's a lot of companies. That's companies across the globe. And at the time of the writing in 2017, they observed that 5% of companies had already moved to containers. So that's a tremendous growth. And the third thing I think is that the Windows container pull count that we see, the number of people pulling our container images and building off of them, has grown tremendously. It's the kind of graph that you want to see. It's trending up and to the right. In July alone, 4.4 million container images were pulled. And we expect this to only continue as the days go on and companies continue to experiment with containers and learn where the use cases are and where they're not appropriate. And we have a lot of customers who are already adopting containers. A few to note, companies like Adobe, Alaska Airlines, Tyco, Jabil, just to name a few. And more customers are coming online to join us in embarking on this containers journey. So now I'm going to hand it back to Taylor, and he's going to tell you a couple customer success stories.
Yeah, some of you probably saw or heard from Aaron in the Server 2019 session about Lindsay. For those of you who didn't, Lindsay's one of our success stories. They're adopting containers. As a company, their goal is to provide better agricultural management to farmers. So their goal is to feed the world or help feed the world. And one of their biggest assets is a technology called FieldNet. So FieldNet allows a farmer to stand in the field with his tablet and understand both the crop conditions, the weather forecasting, how much watering he needs to do, what crop is there, and in real time change the way that he's irrigating his field. Now that application launched back in like 1995. And so over the last couple of years, they've continued to update and modernize it. Well, containers have provided them a new avenue for doing that, one that spans the cloud all the way down to the edge. So they can run applications distributed. And containers have been a key and fundamental part of that. Now they're using both Windows and Linux containers. They're using Azure. They're using all of these technologies together, and the results are pretty compelling. Not only are they saving money, But they also are on a path to save 700 billion gallons of water and 1.2 kilowatt hours of energy by 2022, right? So we love these because it's a win for everyone. It's a win for the company that's saving money. It's a win for the farmer who gets a better way to manage their crop, increase production, save money. And it's a win for the environment. Now, another example is Tencent. So Tencent, a lot of you have heard of them in various forms. One of their big markets is gaming, right? One of the big challenges that we've heard from gaming companies, both Tencent and even our own teams in Xbox, is the size of the backend for the games. These games often tend to be very large to deploy, and so the VMs that were being deployed to manage them end up being 70, 80, 100 gigabytes in size, right? And that both costs them money in terms of COGS, but also, and maybe more importantly, deployment time. So every time they need to make an update to that, they push a whole new set of VMs out through a VM scale set. It can take quite a while for that to deploy. As they move to containers, those images become much smaller. They're much more agile now. So now they can make an update to the back end of the game and push that out to all of their data centers much, much faster.
Okay, so we've talked to a little bit of why containers. We've now shared who containers. The next question that's probably on your mind is then now what are containers? For those who do not know what containers are, let's dive in and let's actually kind of take a look at what containers are. And when I say containers, I think a common image that comes to my mind is actually a shipping container. So much like in this global economy where you're moving goods around the world from country to country, in the same way, software containers kind of do the same thing. So it's a cool analogy. So what does it mean to containerize something? If I was to define it, I'd say it's to package freight in a uniform sealed container for shipment. So what does it mean to containerize software? Well, I really only have to change one word, and that's freight to applications, and you really have the same thing. You are packaging up an application in a uniform sealed container so that you can move it around from system to system. So now let's think about just a traditional system, right? So I've got a host. On that host, I have an operating system installed. And above that operating system, I have applications and services that are running. So your application layer is really your app that you want to run, whatever it may be. It can be in a variety of languages. We have Python, Node.js, .NET. It doesn't really matter. That's your application. From the services side, though, there are other services that run alongside on your host. They're long-running processes generally, and they can provide additional functionality to your application. And then lastly, you have the kernel itself. And for those who are not familiar with the kernel is an entity that provides additional support to your application. So when your application wants to access resources, it's actually going to go through the kernel to get to the resources. The kernel is responsible for fair scheduling of the processes that run on the system and those sort of things. So it's the executive process that underlies everything on the OS. And so above the kernel, you could refer to applications and services as user mode. So you have a user mode, and then you have a kernel mode. Now with containers, all that we're doing is we're taking that user mode, and we're wrapping it up into a package. And in addition to wrapping it up into a package, we also have to go into the kernel, and we have to let the kernel know and let it understand that there are now multiple user modes that exist on top of it. So it knows how to talk to multiple of these packages. And so what you end up having, a system with containers, is you have your kernel still, you can have applications and services living on that host, but you can also have these containers running side by side. And inside the container only thinks it's the only thing that exists. It can't see outside of itself. So another caveat is the host can see into a container, so it can see all the processes running into in the container because it's the host. But from the container's perspective, it's isolated from everything else that's running beside it. So for example, the file system, it gets a limited view. Resourcing, it gets a limited view. Processes, it can only see what it's running. And that's our virtualization boundary, is just above the kernel. So now I think let's visualize this with a task list. So what we have here is we have an application that's running. It's an IIS application. And you'll notice the W3 worker process is running. And then you have your IIS application displayed there, of course. Alongside that, you'd have all other services that are running. When you query task list, you'll see a bunch of other services that are running. And then with containers, though, if you'll just let me hand wave for a little bit with the image in the top right, where you see the command prompt with some jargon there, what I'm doing is basically I'm running a container, I'm getting its IP address, and then I'm opening a browser to that IP address. And so you'll notice that there is an ASP.NET web view that is presented to me, and when I query for the W3 worker process on the host, there's 2 of them. And that's interesting because we're running a W3 worker process in the container, and we're running a W3 worker process on the host. And they even have different sessions. That's how you can tell that one is in a container and one's not. The one that's running on the host is in session 0. The one that's running in a container is session 10. And so the same thing for services. If we query with task list on the host, give me all the tasks that are running and the applications that are running, you'll get back this long list, and you'll see the same thing, where there's a number of services and applications that are all in session 10. That would be the container. And then a number of applications that are running in session 2 or session 0, which is on the host.
So one of the things that we get asked a lot is, kind of back to this, why do we have all these services running in the container as well? In Linux, if you're familiar with Linux containers, you typically have one process running in the container. So why were Windows containers different? Well, one of the things that we had to think about when we built Windows containers was not the architectural purity of this is exactly the way a container is, but it's the use case around it. How do people expect to use it? And in Windows, processes expect and kind of need these Windows services. You want to write out to the event log. Well, you're actually calling a Windows service that writes it out to the event log. That's the way the architecture works. So what we had to do is containerize all of those processes as well. And so our goal really was to make sure that the operating system, that application, could still be portable. Right? And so to do that, we containerize all of the user mode services that applications typically expect to have. Now, the question that I often get with this is, what about the density impact of it? Well, these are all shared memory. So the host is actually sharing all of the memory across them. So the actual overhead of running these additional services is relatively small. But we get the benefit of each container having its own view of the world and its own ability to write things out. If one application writes the event log in one container and another container has a similar application writing the event log, they don't conflict. They have their own view in their own state because of this model.
All right, so yeah, let's go ahead and also dive in and actually see this in action. So here we have a Windows Server host, and I'm not in a container, I'm just on the host. I've got a PowerShell prompt open, and I can query for the processes that are running. And let's find the W3 worker process. Oh. Let's first open it, make sure it's there. Right. 1 second, guys. Technical difficulties. Where is it at? I actually don't see it. OK, well, we'll continue on and let's launch into a container instead. So apologies about that. So what we're going to do here, if you'll just let me hand wave for a moment, we're going to use a tool called Docker to run our container. And this is going to fire up a container, and then we're going to grab the IP address of that container. So we're going to copy this command in. All right. So with that IP address now, we will go and actually open a new tab.
So what actually happened when he started that container is that it booted up all of those user mode services inside that container. So the container, from that container standpoint, it's clean. It's a new operating system with a new copy of every service. It's the first time it's ever been booted.
There we go. It's taking a second to load in, and there we go. So now we have our ASP.NET application that's presented inside the container, and I can query from the host And fingers crossed that this works. OK, so there is the process that is running inside the container. You'll notice the session ID is session 11. For some reason, that's beyond me. I don't understand why the work process is not running on the host here. Or I can't see it, but we're going to continue on anyways. So let's just take a look inside that container. So we're going to take a look at the running containers on our system here. And then we're going to execute a new terminal inside that container. And we'll do PowerShell. OK, so now we are inside of the container. We can poke around, take a look at the C drive. You'll notice a variety of files here, such as the Roslyn compilers, which is needed by the ASP.NET app. And if I go and navigate to the C drive on my host, you'll notice that the view is different. So for example, there's a Windows Azure file folder that exists here on the host, but it doesn't exist there in the container. And I can even make an item, ignite.txt. OK, so there it is. It's now in the container. And I go back to the C drive on the host, and it's not there. So even though the container is now running still on the host, talking to the same kernel, there's some file system virtualization going on. So the container gets its own view of the file system. Additionally, so I'm inside the container right now. I can get a list of the running processes. And let's actually measure that. So there's 23 processes running inside of the container. Let's switch over to a terminal that's on the host now, so we're not in the container, and do task list. And as you can see, there's quite a few more processes that's running on the host. Somewhere I would guesstimate to be like something like 180, I believe. And also as well, you can see, again, as I was talking about earlier, there's the containers processes and services running right there. So back to you.
So one of the big questions that I get a lot is, when do containers make sense? What kind of applications should we be thinking about containerizing, right? Is it everything? What works in a container? What doesn't? And the kind of hard answer is, well, it kind of depends. But we've got some ideas. We've got some things that we can kind of give you to help you navigate it. The things that I would get started with immediately, the things that I would start with right out of the gate, anything that's stateless. So web apps, IIS, Windows services, WCF services, those kind of things are kind of a home run. They're the slam dunk. They're the things that run in a container incredibly well. We get a lot of efficiency out of it. That's usually where I will start with, right? Then there's kind of a set of things in the middle where, yeah, generally they'll work, but there's some extra kind of work and massaging to get them to work the right way. MSMQ and DTC kind of fall in this camp. We know they work, but there's some caveats. Private queues work pretty well in MSMQ. Public queues, there's some challenges there. We're working to make them easier and tool around them and make it easier for people to consume it. But today, there's just some challenges there. Now, one of the really interesting set is stateful apps. So databases. Well, should I run those in a container? The container gets a new file system every time it starts up. How do I persist any data? Well, we have patterns for it. And we'll talk about them in a minute when we get into storage. But we can actually mount storage externally into the container. So we can absolutely do it. And it's totally possible. People are doing it in production all the time. Is it where I'd start? Probably not. Right? I'd start with these easy ones and then build into things like stateful apps. Active Directory authentication. When we first started working on containers, our plan was not to support Active Directory. And I got up on a stage about like this, and I said, hey, containers are going to be great. No Active Directory, and half the room left. Kind of turns out that Windows apps have a pretty high dependency on Active Directory. So we took that feedback immediately and went back to the drawing board, and we figured out a way to integrate Active Directory. There's some really hard challenges with Active Directory and containers. It's not like a VM. If I join a container to the domain and I start up 10 of them, we're going to have a problem. Right? Active Directory is going to say, wait a minute, no. Those are all duplicate machines, and everything's going to explode. If I take a container image and I push it to a public registry after it was joined to a domain, I just gave everybody in the world all sorts of information about my Active Directory that I didn't really want to give them. So we had to come up with a way to bridge that. We did it through a technique called group managed service accounts and the ability to kind of bind a group managed service account at startup into the container. So it's absolutely possible. It's totally doable, and we have a bunch of customers who are using it today. But is it where I'd start? No, I'd start with the easy applications first and then move into that, right? Learn how to do it with the most simple things and then build my skills kind of going forward. Then we kind of have a category here that we're calling there be dragons. Now, people slay dragons all the time in books and on TV and stuff. And I'm sure that some of you are dragon slayers. But these are areas that are going to have a lot of additional challenges with them. So things like that have a GUI to do the configuration. We don't have an ability to kind of TS in the container, and we don't really want one because we're going to talk about in a minute the automation for building the container image. And unless you want to have someone who every time someone says Docker build stands there and goes click, 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 that's not really going to work very well. Now, how do people work around it? Well, they work around it by automating the UIs. They work around it by finding command line proxies for it. So totally possible, but it's going to take a little bit of work. Drivers. So we talked about how containers share the kernel earlier. Well, what happens if one container installs a driver? Well, the kernel has now been compromised. It has state from outside of the container in it. And that becomes a challenge. Now, again, there's a path for it. We have an ability to make a driver container aware. And a set of our drivers, like http.sys, for example, have been made container aware. They know how to deal with containers now. Similarly, things like the redirector for file shares know how to deal with containers now. So yeah, you can do it. It's going to be a lot of extra work, and maybe it's not really worth the effort. Infrastructure roles. So the typical ones we hear about: print servers, exchange servers, Active Directory, DHCP, DNS come up a lot. The biggest challenge with a lot of these is that they are kind of built around the notion that they live forever. You set up an Active Directory domain controller, it propagates its state. That can take quite a while depending on the size of your Active Directory forest, and it's supposed to live forever. So they become a challenging area, and one that we've just figured, it's not really worth going off and trying to change the entire way Active Directory works when we have a technology for virtual machines that work quite well for it. Let's stick containers to where they work the best, which is applications. Right? So this is kind of a map of an area where good place to kind of get started, in an area where I'd probably steer a little bit clearer, at least initially. So what's actually inside a container? Craig gave us a demo. He showed us starting it up. We showed kind of the processes there. But what's really kind of the components of it? So first, let's just think about an application. We've got an OS instance, right? We can deploy a VHD, clean instance. Then we install some dependencies. We go in and turn on a role. .NET 3.5, .NET 4.6, we install Java, whatever those dependencies for that application happen to be. Then we actually put the application on. So we run some MSI, we do an Xcopy, whatever it is, we register a service. And then we do some configuration for that app. We give it some information. Here's your name, here's the department you are, whatever that configuration happens to be, right? That's an application now. Now that's something I can go put in production, I can point people to and say, all right, here's where you go do whatever it is you do. Request the janitor service, or pay my bills, or enter my time and my time off for vacation that I'm going to take next week. Right? That's an application, right? So in a container, we layer this. So we start from what we call a base OS. That is our OS instance, right? And so we'll show this in a second. We say like from server core. That's our OS. Then we install our dependencies. So we have a layer for that. And we say, OK, we're going to install .NET or Java or whatever it is. That's our dependency layer. Then we have a layer for the application. So we actually add the application in. We basically copy the binaries in. And then we do our configuration. Maybe it's setting a registry key. Maybe it's tweaking a config file, setting a web config, whatever that happens to be, right? And that's what represents what we call a container image. And the way we do this is through what we call a Docker file. It's really just a script. It says from that base image, so from Windows Server Core, that's the operating system. Then we give it some information. We give it a label, which is just the metadata. But let's say it's just a comment for the sake of our discussion. And then we do a run. In this case, we're running DISM online. We're enabling IIS. So that's our dependency layer. We're installing the dependencies. Then we're actually doing the application. In this case, we're doing something really basic. We're just echoing hello world to index. So that's all we're doing is setting up the application. And then in this case, we're just setting up a command for it to run. So we're giving it configuration. Right? These are our recipes for how we build containers. Now, we have a couple different base images that we can pick from. We can pick from NanoServer, which is our smallest image. So it's about 95 megs. This was really designed for kind of new applications born in the cloud, target for .NET Core. So if your app's .NET Core or something like Go or Node, that's the base image to use. We have Server Core. This is really our most popular image. It's got our app compat layer. So it's now down to a 1.4 gigs. People who've played with 2016 before, it used to be like 11 gigs, or is 11 gigs. We've done a lot of work to make that smaller. So it's down to about 1.5 gigs now. This has the full .NET framework support. So .NET 3.5, .NET 4.6. This is what we've got people using who have apps all the way back to .NET 1.0. Right? Because .NET 3.5 provides backward compatibility for previous versions of .NET. Right? So this is our most popular image for that purpose. Just this year, we introduced a new base image called Windows. We're really creative with our branding here. And the goal of the Windows image is for more of these automation workloads. So we talked about GUIs earlier. This is the image that people who are doing this kind of GUI automation were asking for. So we want to actually open a UI. It's still headless, but there's kind of this UI that gets drawn in the background, and then they've got automation to go click buttons and do stuff. Right? This was the image that we kind of built for some of those workloads. It carries most of the Windows OS components. It's relatively large because it has everything. It's really just Windows. So it's a 3.5 gig image. But still, that's a lot smaller than a full VHD with Windows in the application inside of it. Right? And we get all the benefits of kind of the automation around it. So we also produce a set of images with the dependencies installed. These are official Microsoft images. We produce them. We maintain them. We patch them. They get updated every Patch Tuesday. So for NanoServer, that includes a .NET image. That has included IIS. We're going to be deprecating that one as we kind of move forward, focusing more on .NET Core. But it's there. And then a PowerShell image. For Server Core, we produce an ASP.NET image. We produce an IIS image. We actually have a couple of other additional ones. There's a SQL image for dev mode, soon to be a SQL image for production. There's a whole list of them. So far, we haven't produced any for the Windows image yet, but expect those to come as we figure out kind of what people are using it for most. Our kind of pattern around this is if we see a bunch of images getting created with these dependencies, we just produce an official one. And then we validate it and verify it and keep it up to date so everybody in the world can just use that to start from.
Okay.
So let's actually switch over. We'll take a demo and see this in action.
So building a container image is not a difficult process. So what I have here is a very simple Docker file that I'll show you, where we're specifying from this ASP.NET image that Microsoft has produced. So we're going to layer on top of that, which that itself is based off of the base images that Taylor was just describing. So there's this really neat effect where you can layer images on top of one another and save the work that's already been done. So we're going to specify from that image, and we're just going to copy in a folder that contains all this data called publish into the www root inside the container. And I'll go ahead and show you. This is the folder that I'm copying in. As you can see, it's really just basically a ready-to-go package of the ASP.NET app that I showed you earlier. And so there's two things that we can do. First of all, we can actually build this container image up in the cloud with Azure Container Registry tasks. So I'll kick that off and demonstrate that. And then secondly, of course, you can build this container image locally. So we have the Docker file on the desktop there beside the publish content that I want to put into it. And let me just go and grab this command here. That's the ACR task. And build the container image. And so what it's doing is it's layer by layer executing the instructions. So because we already have the ASP.NET container image on our machine. We don't have to pull it down. It's already there, so we can just use that. The next step is to then copy in all that stuff into the container image, and then it's done. It's really that simple. It's quite easy. And when we look at the images that are on our machine now, you can see IIS sample, which is what I've built right there. And I'm not going to wait for the ACR task to finish because it actually takes a few minutes because it has to pull the container image in the cloud and then it'll run through the whole process. But just to show you that this is something that you can do locally or up in the cloud. So could you switch me back over? So now that we've built our container image, let's talk a little bit about where we store these container images. Containers are stored in places called container registries. They can be public or private. And container registries exist to the container and manage the container images. And two examples, actually, would be these two right here. So I've created two container registries, both with the same name, but in different container registry providers. So the one on the left is on Docker Hub, which is a public registry we'll talk about in just a moment. And then the one on the right is a container registry that I've actually created up in Azure, and that's private. Only I can pull those container images, or I could give access to other people's container images. And so Docker Hub, as I was saying, is a large public container registry. This is where you would go to explore and find container images, and you can pull them down. All the Microsoft published container images, like the base images, the ASP.NET images, they all live on Docker Hub, and you can go and easily find them there. And so now Azure Container Registry, I mentioned earlier that I had a private container registry built up in ACR. What this is it's a service in Azure where you can go and get a private container registry. You can integrate it with other tooling so that triggers can fire whenever you commit code into a repo, and then it'll go and do things to make the new container image and push that back into your container registry in Azure. It can span across multiple regions, so it's globally available, that sort of thing. And lastly, what I showed you with the demo with this building the container image in the cloud is using ACR tasks, which, exactly as I was saying earlier, it lets you build in the cloud where your registries are. So you're building your image closer to where your registry lives.
Yeah, and real quick before I go into more on storage and networking, just a little bit on kind of the Azure Container Registry and kind of the way that works and why we spent some time talking about it. I mentioned every Tuesday, every Patch Tuesday, we publish a new base image. It's the base image with all of the Windows updates in it. So we're taking care of updating your image for you. How many people would have liked their VHDs to have been auto-updated by Microsoft for you? Yeah. I guess some people don't trust us, but yeah. But we publish a new base image, comes right out of our build lab, and then we run, using Azure Container Registry, we build those new dependencies. So what we actually have is a notion of triggers. So every time we update that image, a trigger gets fired, and every image that's dependent on it reruns its build as well. And every image that's dependent on that reruns its build, and so on and so forth. And then you get an event that says, hey, our image has been updated. So let's say you had an image that was dependent on our IIS image. Patch Tuesday comes around, we publish the new image, and generally within a few minutes, you're going to get an alert that says, hey, there's a new image available. Now, you can do with that what you will. You could automate doing some CI testing and put it into production automatically. You could automate that as just an alert to you to go validate that and put it into production whenever your next cycle is. You could get an alert to say, go look at what was in that patch payload and decide if it was relevant for you or not. You can do with it whatever you want, but we provide that full infrastructure. We can build this whole pipeline so that applications get auto-updated. Now, similarly, if a developer had made a change to the application, that can also trigger that event to just rebuild the image. So that will automatically do the rebuild, and it'll do the same process. You get an alert. You can do with it what you want to do with it. You could run it into production. You could get an email to review it, whatever that happened to be, right? So it gets this fully automated pipeline of build, right? That's why it's so valuable. So let's talk a little bit about how some of this actually works under the covers. We'll take some questions at the end. So within the container, we mentioned earlier, we've kind of got this file system, right? And it's got its own clean copy of it. It doesn't see anything from the host. How do we make that magic happen? Well, what we actually have is a new kind of file system. It's a union file system. It's a virtual file system. So containers, unlike VMs, don't boot from block storage. They boot from files. And on the host, all of those files exist. So it's in C:, program data, Docker, graph driver, something. I can give you the full path. But if you dig into that far enough, you will get a view that looks like the image on the bottom here that has all those files in it. Now, reality is that those are not real files. Those are actually pointers to where those real files live. Because the containers layer on top of each other. So if I have two containers that have the same base image, I'm not making two copies of those files. I have one copy of it, and I have two pointers to it. If a container changes one of those files while it's running, we change the pointer to a real file. We call that a scratch space. And we give that container its own copy. But only if it changes a file. So we get this efficiency. And that ability to track those changes is what makes the Docker file and Docker build work. So we do a Docker build. What we actually do is start up a container. Any changes that it makes to the file or the registry get copied off into this scratch directory. And when we stop the container, we just grab that scratch directory. We keep all those pointers, and we say, OK, if we ever want to start that container up again, we'll plop those down. We'll kind of rehydrate them as the pointers back to the original base. So we make this union. The real files from the base image overlaid with the files the container has changed, and the registry as well. And that's what we actually have inside of the container. Oh, and I had to build up for the slide that said all that. So I talked about persistent storage a little earlier. So we can actually mount a folder from the host into the container. Again, it's just a pointer. So the container says, I see C colon my volume. Well, C colon my volume has been pointed to F colon my volume on the host. We've just told the container when it started up to make that association. So anything we write to C colon my volume gets written in reality to F colon my volume on the host. Right? We're using that same kind of overlay, that same kind of ability to redirect to where the files get written to. Right? And this is what allows us to have persistent storage. You'll hear this as persistent volumes or persistent claims or volume plugins. All it really is just changing the virtual file system in the container to know about some more of the host. Right? It's this ability to point things around. Networking. Networking is another really interesting topic. So each container gets their own kind of isolated network view. So if I actually think about like a IS container, it's going to be on port 80. That's or 443 if we're good security-minded people. And obviously, if I run two containers on the same host, both of them on port 80 or 443, I'm going to have a conflict, right? So what we actually do is we map things. So in the container, when we build the container image, we say, hey, I'm going to need port 80. Now this is handy for two reasons. One, if I'm looking at that, if I'm thinking about it from an ops standpoint, I can look at that Docker file and see exactly what ports have been exposed out of that container. Because if it's not in the Docker file, it's not getting exposed. Or as part of starting the container up, you can override it there. But if a developer says, I'm going to expose port 135, and that's not supposed to be exposed, it's pretty clear. It's right in the Docker file. Right? And we can have a conversation about security practices and why that's probably not a great idea. Or why that application needs that and whatnot. So I would say in my Docker file, expose port 80, and that container would say, great, I know I need to be on port 80. Now, when we actually run the container, the host is going to say, OK, I can't give it port 80. I'm using port 80, or port 80 is in use. What I'm going to do is I'm going to virtualize that, and I will give it port 7935, or in this case, port 8080. That's what the port I'm going to publish out of the container. Right? And the host knows that, and Docker knows that, and then it tells that back to the orchestration layers that can then redirect that port from like a load balancer or whatnot to that port on the host. So each container thinks it's on port 80. In reality, it can be on any number of ports on the host, either statically defined or automatically or dynamically defined. We also have a notion of kind of overlay networking, where we can use software-defined networking to stitch everything together. So we can have two containers that need to talk to each other. They can think that they're talking over some 135 or whatever port it happens to be. And the overlay networking can actually make all of that happen transparently and securely so that only those containers can talk to each other and nothing else can talk to them. So networking is a pretty cool and dynamic concept. We could spend an hour just on networking easily. Unfortunately, we only have an hour and 15 minutes to talk about all of it.
OK, so let's switch over real quick and talk about some container tooling. So I've been using in the demo Docker to do all this container execution stuff. What Docker really is it's a container tool chain. And think about it as an engine that lives above the host, or on the host, but above the OS. And it basically just calls down to the host to say, hey, I need to run this container. Could you give it to me? Or I need to build this container. Could you please do this? So it's a tool chain that helps you, the user, to manage those containers, to run the containers, stop the containers, that sort of thing. And for Windows 10 client, we have Docker for Windows, which, as you can see there, there's a whale icon that gets installed down in your tray, and you can use that to run containers on Windows.
All right, so we're at Ignite. We're talking about production scenarios. So how do we think about managing containers in production? First, this is going to be a bit of a crash course. We have a lot more sessions that go into a lot of detail on this that we'll point to at the end. But we're going to cover the high-level concept. Broadly, we talk about running containers in production as orchestration. So how many people have used vCenter or System Center Virtual Machine Manager? All right. Those would be VM orchestrators. But of course, because it's a new thing, we had to give a new name. So we call it orchestration, container orchestration. So orchestrators do things like schedule. They do things like scaling. They do things with like anti-affinity or affinity. Don't put all of the containers for this web app on the same host. Thank you. Spread them across the different hosts and different racks. They can do health monitoring. So is the application actually healthy? If not, restart the container. They can do failover, all of the things that we would normally think about and see in something like System Center or vCenter or Azure Portal, right? Nothing too scary here. There are a couple different choices of orchestrator. The two that are definitely leading the pack right now, Kubernetes and then Service Fabric. OpenShift is a variation of Kubernetes. So OpenShift uses Kubernetes as part of it, but that's kind of a brand name for it. And then Docker Enterprise Edition, which previously was based on Swarm and is now starting to move into Kubernetes as well. So all of these are ones that we talk about with Windows. Service Fabric is generally available today. You can use that in production. Docker Enterprise Edition 1.0 is generally available. You can use that in production today. That's what a lot of the customers we talked about earlier are using. So Tencent Service Fabric. Lindsay was a Docker Enterprise Edition customer. As we look forward, we're expecting Kubernetes, we're in beta for that now, to be generally available later this year, with Red Hat OpenShift support coming early next year, and then Docker Enterprise Edition 2.0 coming later next year, as well as all of the cloud services. So AKS, Google, and Amazon all have Kubernetes services that we're looking forward to having Windows support in. Right, so these are your kind of choices for orchestrators. And again, these orchestrators do all of the scheduling. They do all of the kind of management of the containers. So Service Fabric, we'll dive in a little bit deeper on it. It's really a combination of two things. It's a microservice platform. And what I mean by that is you can write an application to it and take advantage of things like reliable collections. So a developer can write code that says, put this object into a collection and make sure that if that machine dies the second that I put it in the collection, that it's rehydrated on another machine and that collection is in memory there. Really powerful. We use this for most of our production services in Azure. Right? That was what it was born to do. We taught it how to use containers. Why? Because it's really handy to be able to take the existing code we have in a container and bring that into one of these platforms and then start to build new services around it. So now we have this opportunity to marry the existing code that we have without changing it to these new kind of paradigms and patterns. Right? We have a new variation of this called Service Fabric Mesh that's launching that is a fully managed version of it. So you can go to Azure and just say, yo, Azure, give me some Service Fabric, and it will take care of all of the health and maintenance of all of the orchestration components, the versions of the service, keep it up to date, all of that for you. So we've got a whole set of sessions dedicated to this. Really popular technology. And then we'll talk about Kubernetes. So Kubernetes, open source project. We've been participating in it for a number of years, both on the Azure side and on the Windows side. Brendan Burns actually moved from Google to Microsoft, one of the original founders of Kubernetes, as part of our Azure Kubernetes service team. And so we've been working really hard to add Windows support to this. It's in beta now. I mentioned earlier, we're expecting to GA that this fall with probably 1.13. We've got a breakout session tomorrow morning on both orchestrators. So we'll spend half the session talking about Kubernetes and half the session talking about Service Fabric. Right? So if you want to get into deep detail on how these work, that is the session to go to. Patrick Lang, who used to be on my team, has now joined the AKS team. Sad to see him go. Working directly on Kubernetes. Is going to talk about that side of it, and then Monty from the Service Fabric team talking about the Service Fabric side.
All right, so let's give him a teaser of orchestrating a container.
Oops, wrong one. And if I can switch to the right machine.
There we go. So what I'm actually going to use is Docker Compose, which Taylor mentioned earlier as part of Docker EE. And I'm going to first initiate the orchestration coming up, and then let's talk through what it's actually doing. So what this does is it reads in a Docker Compose YAML file to create the services that I need and to define the relationship between them. And so what this actually looks like is this right here.
And this looks scary to start with, but it's really pretty simple.
Yeah, so if we just kind of parsing through line by line going down, you specify an image that you want your container to be based off of. You can specify the ports that you need to be open. You can add environmental variables to the container. So in this case, the application that we're running is actually a call center application for cable outages for an imaginary company called Fabricam Fiber. And the way it works is there's a web front end, and then you have a database layer. And we're going to run each of those in their own containers. So what this means is we have 2 containers defined as part of our services for this YAML file. We have the SQL Server database that's going to be running, and we need to know some information about the database for the front end. So this is where we're using this definition to inject some of the information state about the database container into it. And so you can do some other things well. You can get pretty fancy with it and specify and tweak networking and do other configurations. But the high-level idea is that when you're orchestrating containers, for any orchestrator that you're using, Kubernetes or Service Fabric, what have you, there's going to be a definition file that explains, hey, I've got these services. They're going to be wrapped in these containers, and this is how I want them to talk to each other. OK, so now we have the containers up and running. Let's go ahead and take a look at the application. I'm going to grab the IP address of the front end and just open a tab to it. Fingers crossed. If this works, you'll be greeted by a nice gentleman with a bunch of service requests on the side. So let's give it a moment here. Is there anything you'd like to add about the demo?
Yeah, I mean, the one thing I would, so you saw the password being hard to find in there. Patrick will actually talk about that tomorrow. But that's actually one of the nice things you get out of this kind of configuration is I get to look at that and say, wait a minute, you're defining a hard-coded password? Like, no, we don't do that, right? And the orchestrators actually have a nice way of doing what's called secrets. So I can go in and build a secret. And every time I deploy the application, a new secret is generated. And that secret is handed to the container securely. So the containers, the database and the web front end, get a random password each time that is defined as a secret. It's called out as being that. And the orchestrators have these great kind of capabilities. So I get this opportunity to go have a conversation about security and actually enforce some better practices as part of deploying the application.
Great.
And in the meantime, we've got FiberCam.
Yeah, we got it up. And if we take a query of what containers are running, you'll see right there, this is our database container and then our front-end container. So back to you.
Yeah. All right, so let's talk a little bit about Windows containers in the cloud. So first, I'll kind of start off. We have Windows container support in all of the major clouds. So whether you're an Azure customer, I hope many of you are. If you're an AWS customer, we have container support generally available there through ECS, as well as through virtual machines. And if you're a Google customer using GKE, you can spin up a virtual machine and run Windows containers inside of it. We also have support from a number of the other clouds. Huawei in China has support for Windows containers, for example, and many of the other ones. We'll talk a little bit more in depth here about Azure. So we have a couple different services available to run containers in Azure. I kind of make this joke all the time here. It's Microsoft. If there's a good thing to do, at least 3 teams are doing it. Containers must be really great because we have 4 teams doing it. So we have 4 different ways that you can run containers, not counting just running your own VM. Azure Container Instances, this is the ability to just say, hey, Azure, give me a container. Here's my container image. Just run it for me. Super easy. We take care of all the infrastructure. We take care of dealing with Docker and all the orchestration. We just give you a container out of it. We have AKS. AKS is, so we've got a preview of this now for Windows. We're expecting to have it available in public preview later this year. So this is our Kubernetes service. This will both tie into ACI, so the ability to have ACI actually generate the container for you, or as a hybrid cluster of Linux and Windows VMs that are going to be managed by it. We have Service Fabric. So Service Fabric we talked about earlier. And then we also have, in preview, App Service. So App Service can run a container now. So we've taught App Service how to do more than just run web packages. It can actually run a container as well. So one of the questions I often get is, which one of these should I use? Well, if you're building a container that's only for web, I would certainly be looking at web app. If the container is doing more than just web-based things, so it's running Java applications that are doing random stuff, it's a database, those kind of things, that's not really where App Service or web apps shines. So I'd be looking at Service Fabric or ACI or AKS. Between Service Fabric and Kubernetes, that's a really hard question. That's like Ford and Chevy. Everybody's going to have their opinion. Their opinions are probably well-founded. It depends a lot on what you are looking for. Kubernetes comes from kind of the Linux world. It has an ecosystem around it from that. We're bringing Windows into it. Service Fabric comes from the Windows world, has an ecosystem around it from that. We're bringing Linux into that. Ultimately, both of them are going to have similar capabilities, and they're going to have some differentiation. So it depends on what works best in your environment. If you're going to build reliable applications and you like the reliable collections model, Service Fabric hands down. If you're coming from a Linux community, you've got Kubernetes already, that's probably a better place to go.
So again, just giving a quick teaser of 2 particular services that we do offer in Azure with Service Fabric Mesh and then AKS for the next one. And do go to the session tomorrow with Mani and Patrick if you'd like to know more. But with Service Fabric Mesh, the idea is that you get out of the business of having to manage the underlying infrastructure. So you provide your containers, and it will run particularly microservices and serverless. So you don't have to worry about storage and the networking and the infrastructure underlying it. And then with AKS, so traditionally with Kubernetes, what happens is, much as I gave that definition file to Docker Compose to run, with Kubernetes, you would give a definition to this Kubernetes API endpoint, which is then going to pipe into this control plane, which you have to manage yourself, things like the API server, etcd, et cetera. And then it would schedule those pods on your VMs. With AKS, though, we take that away from you, and we say, hey, let us manage the control plane. You don't have to pay for it. We'll manage it. And you just worry about your VMs, basically. And so, yeah, Patrick and Mani will talk more about this tomorrow, but just at a high level, AKS, think about it as a managed Kubernetes offering that we have in Azure.
So when we think about a lot of our customers that I talk to, really hybrid is an important point for them. So I talked to a lot of customers who come through our executive briefing center who have had cloud beaten into them over a number of days and sometimes weeks. A lot of customers come to Seattle and they go visit Amazon and Google and Azure, and they hear cloud, 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 cloud. And I think there's a reality for many of them that I'm on-prem for a reason. I've got services that are on-prem. It's not going to happen overnight. Maybe I want to go to the cloud. One of the great things that we've found with containers is that they give us a lot of the agility and benefit that we get out of the cloud, but we can bring them on-prem. And so a lot of times I end up spending a good portion of an hour saying, okay, here's how we can start to leverage containers on-prem and get some of the value of kind of this cloud model. So now I've got this redeployment model. I can start to build my own kind of similar PaaS services. So here is our standard SQL image for all applications, right? I can start to get some of those benefits. And I can take some of our legacy applications and start moving them into containers so I get the redeployment and the consistency. And ultimately, that's going to help us move to the cloud later on. Because once I can easily redeploy that application on-prem anytime I want, I can start to test and play with the cloud and have confidence that I can move it forward, right? And maybe that's a year down the road. Maybe that's 10 years down the road. That's fine, right? But I can also start to take advantage of cloud services for the containers themselves. So I can start to use things like Azure Container Registry and Azure Container Build, or Azure Container Tasks, to build those containers in the cloud and bring the images on-prem, keep all of my data on-prem. So I can start to bridge some of these gaps between the two, right? And we've got a couple of different services around that. So we talked about OpenShift, we talked about Docker EE. Those are available on-prem or in the cloud or in both. And so one of the last ones I want to kind of talk about and just leave you with, we talked about this in Aaron's session and we get a demo of it. We're announcing it this week. Container tooling for Windows Admin Center. And so I'll kick over to my machine here. So in this case, I actually have my my environment fully in Azure. I'm doing the best practice. I've got 2 different regions. I've got some monitoring on it. So in this case, I can see that I've got some CPU that's a little bit abnormal. It's high. And so I'd want to go dig into what's going on there. And so within Windows Admin Center, I've got the ability now to go look at the containers that are running. Now, this could be running on-prem. In this case, it's running in Azure, so I'm actually using this within Azure VMs. But this is fully available anywhere that you can run Windows Server. And I've dug into this new Containers tab on one of the servers. And what this lets me see is it lets me see a summary of all the containers running, and I can get into details on any individual container. So in this case, I've got one that's called test factorial that's running at 70% CPU. It's a pretty high CPU. That's probably what's causing the high CPU. I can see that in the logs. I can see how much memory it's consuming. Right, so we talked about memory earlier. This container is only using 90 megs of memory. So it's doing all this work, pretty small amount of memory. I can see how much network it's using, all from within this portal. Now, we didn't give the ability for Windows Admin Center to create containers, do all that. That's kind of the job of the orchestrator. Instead, we decided that, at least to start with, let's work within kind of the confines of the orchestrator. So I've given it the ability to stop the container. And so in this case, what would happen if it was under orchestration is that container would probably get restarted on another node from a clean image. And hopefully, it wouldn't have the same issue of running high CPU. So I've just mitigated that issue. Now in the morning, I can talk to the dev and say, why is your container running amok? I also have the ability to kind of dive into the container in more details. And so I can go in and get the event log. This was one of the key requests that we got from our ops folks. How do I actually get the logs out of a container? So this is going to take a second to populate because we're populating the entire event log from the container. But now I can go in, I can look into the application event log. I can get all the events that are in there. I can filter them. I can sort them. I can clear them. All the things that I would normally expect to be able to do from the event log. This is all remote, so I'm not actually having to connect into the container to do any of this. I can do it all from this dashboard. So here they are. Now I could export that, show the dev team in the morning, hey, this is what happened. I mitigated it by restarting the container, right? I can also get the console for the container. So Craig earlier showed I could say this docker exec command. Well, if I don't want to deal with any of that, I can just right from here click on the console. And now I'm actually connecting to distracted Minsky. And I'm actually in this container. So just like we showed earlier, here's the file system from within the container. All of this is available through Windows Admin Center. So this is available now as a preview. Our real goal for this was to start the conversation about Windows Admin Center tooling. So please, give us feedback. Either stop by the booth, find us on Twitter, whatever works best for you. Let us know what you want to see in Windows Admin Center. What things would make your life easier. We really think that this is going to be a pretty valuable tool and kind of path forward. And so we mentioned earlier some of the different sessions as we're midway through the week. A number of the sessions have already happened, but of course they're all recorded. You're here today from Ops DevOps. Tomorrow we have orchestration. We have a session on building reliable microservices with .NET Core and some best practices for Service Fabric applications and clusters. On Friday, for those of you who are early birds, we've got the tooling for containers. So don't have too much fun at the party, and you can come back for more fun with tooling with containers, as well as a session on microservices there as well. We will be down at our booth for most of the rest of the day today. I hope to see a bunch of you at the Windows Server party tonight as we celebrate Windows Server 2019. We're pretty excited about it. Pretty much everything across containers has been updated from 2016 to 2019. I was trying to think the other day of one area that hasn't had some improvement or change in it, and I can't think of one. So we're really excited about that becoming generally available. And with that, we've got a couple minutes for some questions. And again, if we don't get to you, come by the booth, and we're happy to answer them. If you can use the mics, that would be very much appreciated. I will try to repeat them if I hear them. The question was, to use OpenShift, are we going to have to use are we going to have to join a Windows host to an OpenShift cluster, or are we going to be able to run it directly? So the masters will, at least for now, remain on Linux. And so it'll be a Linux set of masters, and then you join Windows nodes into that cluster. We have a design in mind for how to kind of bring that over using Linux containers on Windows, but that's not going to be the initial kind of focus around it. Yeah. So the question was, so if I'm a Red Hat customer and I'm using the Red Hat registry, are we going to be populating Windows containers into the Red Hat registry? Great question. We have built a federation model, and so we're working that through kind of the details now. All Windows images, the Windows-based images, always come from Microsoft. That's been true from the very beginning. And basically what we did with Docker Hub is we found a way to make a nice pointer to it. So we're working through the same kind of details with Red Hat so that all of those images will be available as Red Hat certified images, but will still be catered from a Microsoft repository. And then Security Center integration in Azure, that is coming. We've been talking to the team about it. I don't have a lot of their details on the roadmap for it, but it is coming. Yep. Yeah, so the comment was, yeah, I'd like to be able to go in Security Center and see all of the containers that need to have updated images. That's exactly the kind of integration that we've been talking to them about, as well as scanning of images. So I've layered 7 things on top of it. Are those all secure now? So expect to see some of that coming. I don't have a timeline for it, but it's definitely on our roadmap. Pivotal Cloud Foundry, friend or foe? I partner with Pivotal. So actually, Pivotal Cloud Foundry now uses Windows containers under the covers. That's a new kind of evolution for it. At the end of the day, I'm happy if people are loving to run their applications on Windows Server, right? That's my thing in the world is love Windows Server. I'd love you to love Windows Server on Azure. I'd love you to love all of our services. But if you're happy with Pivotal Cloud Foundry, be happy with Pivotal Cloud Foundry. I have no gripe with that personally. Licensing question. Do you have to purchase a license for every Windows container? No. A standard license will give you unlimited kernel-isolated containers and 2 VM-isolated containers. A data center license will give you unlimited of each. So it's a very favorable licensing model. Question was about static IPs. You can give each container its own IP address. Yeah, that is possible. It's a little bit of an anti-pattern, but it is completely possible to do. Yep. Let me grab a question from over here.
So in the scenario that we're scaling out these containers, what's the story around load balancing or dynamically load balancing, given we have these virtual port mappings and containers picking up whatever IP they could possibly come up with?
So orchestration is really what deals with all that. So you give the orchestrator some rules, and we didn't kind of go into that. I'm sure Patrick and Monty will. So I can tell it how many of each container I want up and running. I can also give it rules like if the CPU goes high or if networking goes high, start up additional containers. And it knows about all the ports and can even call back into hardware load balancers or software load balancers to add additional containers to the load set. You might have noticed on the SQL when we actually had a health check. You can actually provide a health check to any container, And so one of the things it'll do is wait for the health check to pass to actually add it to the load balancer set. So it'll warm it up, make sure it's healthy, and then call back to the load balancer and add it into it.
Very cool. Thank
Yeah. You had one more question.
Yeah. I stopped by the booth this morning. This is kind of like FYI for you. They're sold out for tickets for the party tonight.
So we were sold out of 2019 party tickets, I guess.
Hi, just wondering if you have any customers in the legal field that have implemented containers. I work for a law firm, and most of the applications that we use, they're not web apps or microservice apps, but they're like stateful apps. So do you have any customers in that area that have successfully implemented containers?
Yep. Yeah, I mean, it's always a little hard there's a couple segments of customers that generally don't talk publicly. Financial and legal tend to be of those. But we do have customers that have done that. That's where the persistent volume support kind of comes in. So you actually remap things out to a network share or to an iSCSI volume or something like that for that persistent part. So what actually becomes important there is state separation. So knowing where that application is going to write its persisted state to versus kind of its temporal, log files and that kind of stuff.
Okay, so no storage that you can share then?
Yep. Yep, you can still do all that stuff.
Okay.
Yeah.
All right, thank you.
All right. I hope everybody had a great time. Again, we'll be down at the booth, and really appreciate your coming here today.
Thank you.